Hello developers, let's start developing. Today we're gonna take on the day 15 of the 2023 Advent of Code. So the story goes that we reach some facility where we have some things that we need to do. We have a hard hat wearing reindeers and whatnot, and we need to do the holiday ASCII string helper algorithm popularly known as hash. So the first part of the task is basically to generate a hash algorithm, which is relatively straightforward. We need to get the ASCII code, increase it by the current value, multiply it by 17, take it modulo 256. So take the last 8 bits, and move it through a string until we calculate the complete hash. This is very similar to what methods like get or something like that actually do. And they are very useful in general in programming because imagine that you need to find out the duplicates in an array of 52 megabyte strings. In order to compare two strings, what you need to do is basically first character, second, third, fourth, 2 million, 2 million, 2 million and one, 2 million and one. There are better algorithms for comparing strings, but not much better, to be honest. But if we compare the hashes, and if we need to do for the 50 strings, we need to do that 50 times. But using some kind of a hashing algorithm that is actually not that different to this, we will be able to compute a single value for a given string. And that value will depend on all of the content of that string. So that string will always give that hash value, but most likely only that string will get that hash value, which means that if we compare two strings that already have hash values pre-computed, or we compute them then, we can just compare the hash values. If the hash values are different, we know that the strings are different. And the reverse doesn't hold, because if the hash values are different, the strings might be different, the strings might be the same, but uh, the other thing definitely holds. If the hashes are different, then the strings are different. Anyway, that's totally beside the point for the task. We just need to compute some hash codes, and for one, our example is not multiple lines. Our example is a single line with a comma separated values. So we're gonna start with that. So we will need to basically separate this on commas. We won't need the read input lines. We will need the read input, which actually returns a string, and this is the input. And input dot, well, split on a comma. And these are not integers, so we don't need any mapping. And for once, we actually have string array as the type of the input. And now we just need to say, well, for the input, for x, this looks like an instruction or something like that. Initialization sequence or something. Yeah, it's an instruction. For each instruction, get hash for that instruction. And since we will need, that will be a number, we will need to sum it, and that's the result. And we just need to return the result. Of course, we need to compute the hash. If we just say return -1, this will work, and it will return minus 10ish or however these are. Let's see if that works. 15. Yeah, we're getting 60% of the way there, except the second part of task 12, which is still not solved. Of course, by the time you watch this video, it might already be solved, but that's for future VEC. Okay, we have 11 tasks. And what is the algorithm that we actually need to do? For the current character of the string, increase the current value, and the current value is 0. Oh, we cannot. Yeah. So we have our current value. And we're gonna just loop through all of the characters. Do we need to do that? Do we need to take that, or we can use this thing, char code that index, and let's just console log that, because that should be an integer that for this set of values will return the ASCII values, because we're working with Latin script. For the Latin script, the Unicode values and the ASCII values are the exact same thing. I'm using the Cyrillic alphabet as well, and for that it might be the same, it might not be the same. We have 114, 110, and so on. And I think those are the correct ones. Lowercase have that kind of ASCII code, so that's the ASCII code. We'll see. After we get the ASCII code, we increase the current value by the ASCII code you determined and multiply it by 17. So we just need to say current value is current value. And you can see that it already says, oh, you want to compute a hash code in a method called hash code. So here is an example that you might want to do. And it says you multiply by 31, add the character, and then use this as a modulo operator. It's basically the same thing that we want to do, a bit different, but you can also know that we're using 31, which is a prime number. Because in computing hashes, we want to make sure that the hashes are distributed nicely across all the field of possibility. So if we're doing 1 to 256, we want to make sure that we're just likely to get a number under 10 as we're to get a number between 10 and 20 and so on and so forth. Because we want to basically spread them out. But that is not the algorithm that we want to do. We want to increase the current value and then multiply it by 17 and then do a modulo 256. We could actually take this value just by doing some bit twiddling, but I'm very, very reluctant to doing bit twiddling in JavaScript as it was not made for that. So, yeah, so if the string is hash, we're gonna get 52. Let's try that. So the hash of hash should be 52. And it is. Seems like it's working. And for this example, we should have a sum of 1320. It's totally straightforward. I don't see how we can optimize this, but it seems to be working. So let's take a bit bigger input. Actually, we have something like 22 kilobytes of text. And since this is always positive and the average value is 127, we'll get a few 100,000, I guess, as the result, or a million. Yeah, a few 100,000. 513214. Let's see if that is the correct value. Yep, we have that gold star. And now we need to see what we have to do with the hashes. I actually read through this a bit. A friend that already solved this told me that the second part is gonna be easy as well. The first part was, so to say, trivial even. But this Friday, uh, the guy that creates this puzzle, Eric Wasdell, actually decided to give us a gift so that we can focus on the weekend. Usually for the weekend we have the hardest task. Let's see, so we have a large library containing lenses organized. So we have a label printer. Okay, I spent some time reading the description and I think I have an inkling of what happens, but first I will need to do a little bit of changing this. Let's see if I have this string. We already have CM, we already have QP. Let's take PC, OT, and AB, and we already have PC, and OT. Let's just use these things and yeah, we're not touching part 1, but we will do the changes in part 2 so that we don't mess up. This is not really valid, but what I want to do is instead of this, map it and then console log it. Let's see what we get. We should get some low numbers, if I'm correct. We should get zeros and ones and twos. Because we need to do the index and the hash of the items. Yeah, 001333. So it means that Rn is 0, Cm is 0, Qp is, and these are 3's. So what happens now? If we have this Rn equals 1, we need to get a length with the focus power or whatever, focal length 1 and put it in the box 0. And this says remove a thingy, a lens from box 0 with the label CM. We don't have such a label, we don't do anything. And this says QP was 1. Take the box 1 and add a lens with a focal length 3. Take box 0 and add a focal length 2. QP was 3. So go to the box 3 and remove whatever lens has the label QP. That's this one. So you only have that. PC equals 4. We're adding 4 to the box 3. OT equals 9. OT to box 9. AB equals 5. Adding 5 to box 3. Remove PC. Go to the box 3. Take out PC. PC equals 6. Go to the box. Add 6. OT equals 7. Go to the box and remove 7. Add 7. And since we already have an OT, it actually updates it. So that's what happens. Let's go back to the actual demo input. And this time we might need to do some parsing because these are as I thought these were instruction. So basically this kind of instruction says each label corresponds to one and only one box, since that's the hash of the label. So this says in this box put in an Rn labeled length with a strength of 1. And this says remove that length from that box. That's all it does. So we can implement those. So first of all, we're gonna need to do the world, let's say. So we have a result, let's call it, or mirror, or something like this, series of boxes. What is this thing? I want to have a nice name. Let's call it space heater, because it's something that kind of gets data from gets light from the universe and then creates lava. So this will be an array of 26 and 256 items, because those are all the possible values. And it will have what it will have. It will have an array we don't need anything, we can just say that, and it will be an empty array. Different empty array. We never initialize a matrix using this, because that will put in the same array in all of this. So I'm filling it with whatever. This 0 is not used at all. And then I'm saying for each of that generate an empty array. So this will be a empty array. But each array will have lenses. And what is a lens? Is a interface that has a label, that's a string, and that has a focal length. Let's just call that focus. And for each of that, so we are empty and empty just as a lens array. So now we will have my matrix, not a matrix, but a sparse array of lenses. And we're gonna need to loop through the instructions. We have two options, and we can use regexes to match this. And I don't really mind using regexes for this, because we will have two options. We can have a start and then literally anything, and then we will have a minus and it will end. And you can see that we're matching the minuses that way. So we're gonna have minus instruction regex is gonna be that. Set instruction regex is gonna be something else, and that is, so you have everything else, and then you have an equals, and then you have some numbers. Actually, this is 1 through 9, I think. Let's make sure of that. 1 through 9. Great. Which means that we only have a single digit, so we definitely don't want this plus. So we only matched everything else, so this is the other regex and it gives us the label O. And focus. Do we want it like this, or do we want it like something else? We do want it like something else. So this won't be an array of lenses, but this can be an empty object. Instead of having an array, I will have it as an object that has the label as the property and the focus as the value. So instead of having this thing, A3 and B4, because in order to find whether A is contained to this, you will have to actually go through it, but I will have something like this. A is 3 and B is 4. So now we can just say, does this have an A property? If it does, then we're golden. So for each of the instruction, we will see whether that matches. We have a better actually the method is called match. Somebody put an extra. So we can not do that. Now let's do this. So match with that, and now we can say if it matches, get the hash of the label, because we have the label. That's the label, and we're getting the hash of the label, and the hash of the label is the index inside our space heater. Yes. Our space heater value is a record of a string and number, and we don't need to do that. We already have it, but we actually, if we have a minus, we can just use this. So this is our box that we got. Just a sec. One thing that we're missing, so we might still need an array. One thing that's missing is actually the ordering, because it might be important, the ordering. The slot number. So we kind of need the ordering as well. Yeah, so back to the drawing board. Label and focus. And this is edit as lens. So we have the box, and the box is a lens array. And now we can say, does this box contain this label? And actually I'm going to use the other one, find index. Does this box contain a lens with this label. And yeah, let's have it like this, because writing match 1 all the time is tedious. And this L is actually a lens. So the lens index is on the box. We're going to find the index of the lens whose label is the same as our label. If that lens index is bigger than 0, then we actually need to remove it. And that's all that happens. And if that index is less than 0, then we're not doing anything, because it says remove the lens with that label, and we don't have it. And we can say remove it. So we're gonna need to run a splice method on the box that I always had, but that will actually do what we want. It will throw away the ones that we don't need. So this is if the minus match doesn't work. Otherwise, we should have a set test. We need to check the set instruction regex, so set will do a set match. Yep, using that regex. If that regex matches, and I'm just gonna add another else here that will just throw if we have an instruction that doesn't match that or that. I have no idea whether this is correct or not, but we'll take a look at it. So let's see, we have two groups here. The first one is the label, the second one is the focus, and that is an integer, so we're gonna need to do a parseInt, but I religiously put in the base here because otherwise we might get weird things. And then it's the same thing. We're getting the hash from the label, we're getting the box from the hash, we're getting the lens index if it exists. So if the lens exists, we need to replace the focus, otherwise we are adding it at the end. Let's just read through once more to see if this is somewhat correct. So if the operator is a dash, go to the relevant box and remove the lens with the given label if it's present in the box. Move any element as far forward as they can go without changing their order. So basically remove it from the array. If there is already an lens, replace the old lens with the new lens. So just update the focus. And if it's not already a lens, add the lens to the box immediately behind any lenses. So push to the array. If there aren't any lenses, that's the first lens. Well, yeah, that's what will happen if we just do a push. Otherwise, do that. So once we do that, I will just say, well, since we have in the first this input only 0, 1, and 3 as things, I will just say space heater dot slice the first 5 items and then console log those and see the situation that we actually have for the second part. If we are correct, we should get something like this. Box 0 and box 3 should have some lenses. Nothing has anything. Well, something is not working. So let's see what we're doing. Let's try to debug this. Do we have the correct input? That is always relevant. If we do, we can just see what happens here and how we're going to do that. Something didn't go right. We're just mapping and summing, so we're not destroying the input. And we're processing day 13 instead of day 15. So that's an important thing to get right. So we have our space heater, which is right now an array of empty arrays. Empty array, empty arrays, and so on and so forth. For each instruction, we have it's not a minus match, it's a set match. The first one is a set match. So the label is Rn, the focus is 1, the hash is 0, the box is an empty array, the length index is -1, and we need to push to that box. So now our space heater should have a one array that has an item. Let's see what happens if we have a minus match. The label is CM, the hash is 0, the box is the one with the Rn, and we see we have the length index of -1, so we shouldn't do anything. The next instruction is once more a set instruction for the box 0, for the box 1, I think, actually. Yep. And we're gonna push something. So now our space heater should have two boxes that have something, UP and that. So what happens here? Or did we look at the wrong thing? We totally looked at the wrong thing, because instead of saying slice off the first items, I just told it get everything except the first 5 items, and those were the only ones that are relevant. And since we didn't have any commands, it's an empty array. Yeah, so 0 has Rn and Cm with focuses 1 and 2, and 3 has OT, AB, and PC in that order with focuses 7, 5, and 6. Looks like we are correct. Now we just need to focusing power of all of the lenses of a single lens. So we need to go through all of these and maybe flat map them somehow. Let's see. Now I would like to do something like this. Get that space heater and flat map it, but using this format. We're gonna have the box and the index, and we're gonna, I don't even need whether I want to store this, and I definitely don't want to for each it, but let's see what I want to have. For each box, and this is a lens array, and each index, I'm gonna return an array where I map. No, this is the box ID actually. We need the box ID, and then we need the actual index, and then we need the focal length. We don't actually need the label. So we need an object that has the box, which is the box index. Now we kind of actually treat this as a matrix, so to say, and the box index is our, let's call it row, and the length index is our, call it column. So we not want to have an object that has a box that has a length number, which is the index, and we need a focus, which is the length focus. Multiplying together 1 plus the box number Okay, so we're not using the index because the index is a bit zero-ish, because it's an index, neither for the length nor for the slot number, and then the focal length. So 111, and we get the lenses. Let's see what we get. We should basically get something that's in line with this calculation. Only we won't have the labels because we kind of don't need the labels anymore. 111, 122, yep. 417, 417, 425, 436. Looks correct. And now we're gonna need to do one more thing. The result is taking these lens powers and summing over for each lens the multiplication of the box times the lens times the focus. We just need to return the result. And for the small thing, small input, it should be 100 and 145. So 1320 and 145. We are correct. Once more, take the full input, all 25 kilobytes of it, and paste it, and run our code. I don't see this being too slow, but to be honest, I don't see it doing any optimization on it because it's just following some instruction. It's a straight up simulation. I don't think that we can optimize it in any way. But it's 9 milliseconds, so I can live with that, especially if this number is actually correct. Let's find that out, and that's the right answer. So we have 29 gold stars. We are way over half. We have almost 60% of the stars as long as we get that pesky second star on day 12. So keep developing and see you soon.